Are you ready for me? All right, so before we start, I want to just do a quick test to see if you actually can really see me. And come on, put up your right hand. I'll put my right hand up. Okay, good. Okay, because we're going to need that hand. We're going to need that hand in a moment. So put it down. Don't keep it up all day, otherwise we get very tired. I'm really unhappy that I can't be in Estonia. I really was looking forward to beer mixed with honey that you have in some of your amazing places. Another time, a bit later, I really liked it a lot. In 2003, I went when it was really cold and freezing, and it was the first time I saw so much ice, and you know, the whole sea covered with the thick layer of ice is quite amazing for me coming from South Africa. Anyway, let's look at Lambdas and how we can write Mixins in Java. The first part of the talk is really very basic. So I'm Heinz Kabutz. I'm a Java consultant. The sea, so you can see it's quite a nice place to live. We have an annual conference there called JCrete, which unfortunately sold out for 2015, and yeah, you've got to get in really quickly if you want to get in there. And we're trying to figure out how to decide who can come in 2016, because it's just, you know, we've got 70 places and they go away really, really quickly. I also create the Java Specialist newsletter, which I'm the biggest idiot in the world, but I got a little bit confused when I started looking at it. And I got confused by a few things which shouldn't have confused me, but they did confuse me. And, you know, we in Java 7, we could do this. We could say new thread. We can construct anonymous in a class, runnable, and we could say public void run and then call say hello. All right. Now, and then that say hello method would then call the private method say hello, right? But in Java 8, what we can do is we can use lambdas, and I'm sure by now you've seen this a few times already. This weird syntax where you say new thread, and then you've got this lambda over here, open close bracket, and then minus greater than, and say hello, and then dot start. And this is nothing new. I mean, lambdas have been with us for, I don't know, 70, 80 years.
That's the internet connection.
Things about Java is that they try to be backwards compatible as much as possible. So they don't want to do anything which will break Java classes that have been written already, that have compiled, that work. So this means you can take a jar file that you constructed in Java 1.0 and 1.1, and you can take this jar file, you can use it in Java 8, and it should work without having to recompile your code at all. This is one of the big benefits we have with Java. Now, because of this constraint, they try to make sure that Java situation where Java 1.1.1.2 and 1.3 where you can't use old classes. Well, never is of course a bit excessive. There are sometimes cases where Java, which we don't have with other languages. This means that in Java we've got to be very careful how we let the language evolve. Now, a functional interface means you've got exactly one interface, one method, one abstract method. And this looks easy on the surface, but it actually can become a little bit tricky. Now, it has been interfaced, first of all, of interface and class, which is not really a natural object-oriented separation. It's more superficial separation within Java to try and differentiate between those objects which contain methods, real method bodies, and those that don't. And of course, in Java 8, this differentiation has also gone away. So if you look at this little interface here, public interface run, nibble, public abstract void run. Now, the first question is this a functional interface? Now, what we're going to do here, the people who are connected via webinar, if you say yes, you can put up your hand. There's actually a little hand icon you can click. And those in the room, if you put up your hand, then I can get some gauge of where we are. Well, the first one's very easy. You should be able to figure this out quite quickly. Okay, so I can see there are a couple of hands going up. 1, 2. And in the audience, anybody in Estonia? Is this a functional interface? Yes or no? Come on, put your hands up if you think it is. Please. Come on, don't be shy. I can see you. You're very shy. There we go. Thank you. Thank you very much. I appreciate it. Of course, I forgot that Estonia is made up out of Estonians and Russians, and it's going to be a bit difficult getting Estonians to put up their hands. But we'll try and get you by the end of this talk. So, thanks to those of you. In Java, you don't have to say public abstract. The methods are automatically public and abstract. So because this is a functional interface, we can use it as a lambdas. We can say thread pool.submit and pass in a runnable by using this lambda syntax of the brackets and then minus greater than say hello. All right, now we get a little bit more difficult. We've got here an interface called Action Listener. Now you might not have seen this Action Listener before, but Action Listener extends Event Listener, and it's got a method called Action Performed. Now you've got to be careful here. Who thinks this is a functional interface? I'm going to put my hand up so you can see that hopefully. Okay, I can see a hand going up there in the back. Thank you very much. Nobody else is brave enough, or you're all too shy to put up your hands. You're like my third daughter who doesn't want to put up their hand. It's okay. And I see there are two more people putting up their hands remotely, Bernard and Juan Diego. Thank you very much. Okay, who says it's not a function interface? Okay, so Michael says it's not a function interface. Now, the thing is, actually, you can't really say, because and if you look at the parent is Event Listener, and Event Listener doesn't have any functions at all. So therefore, Event Listener is not a functional interface, and because it isn't, we can conclude that Action Listener has exactly one abstract public method, and therefore we can say that it is in fact a function interface. So thanks for those. What I want to do is I want to make sure that a class implements the toString method. So I've added a toString method into an interface, and if my method implements that, then I'm forcing it to have a method toString inside. So who says this is a functional interface? Let's put up your hands if you think it is a functional interface. Okay, get some hands up remotely. Slowly, I can only see part of the audience. Okay, Yes, so you're not putting hands. Who says it is not a function interface? So one person said it is on remotely, and who says it's not a function interface? Okay. Hand at the back there, very good. Thank you very much, appreciate it at the pillar. So that is good answer. It actually is not, and the reason it's not is because the toString method is a public method, a public non-final method inside object. Right? So this is not a function interface. Now, if you look at object again in Java, object has been pretty much the same since Java 1.0. These methods have all been available for a very long time. And you can see that some methods you cannot override. So for example, we've got some final methods you can't override, and some protected methods which you could override with public methods, and that would work. But otherwise, you don't really, some you can override, some you can't. Now, final methods cannot be added to an interface. If I've got an interface which has a final method inside, like notify or notify all, it won't compile. So sorry that you can't put that in there because it's a final method. So those don't count. We don't care about the final methods that are sit inside the interface. What about non-final methods? These methods are public non-final methods, and we can add them to function interfaces. And well, if we have one of those inside a function interface, it doesn't count towards the count because they are public anyway. So in the previous call, previous example, we had a toString method. The toString method is public, and so therefore it doesn't count towards the total. But we've got two other methods like finalize and clone, which are protected. So these are not public. Therefore, if you put a public method called finalize or clone in equals, and I've got bar1, which extends foo, and it's got a compare method. Now, foo1 is not a function interface because foo1 has an equals method, which is already a member of the class. Now, there's actually a case in compare and a comparator where they've got an equals method and a compare method. I'll show you that in the next slide. So equals doesn't count. Bar1 extends foo1. This method has exactly one abstract public method, so it does count. And here we've got another one, comparator, which is very similar. I think this is quite clear that it's a function interface because we do have a public abstract method Boolean, and then we've got a compare method, which we have to override. So this is a function interface. Okay. Anybody, the remote people? Okay. Putting up your hand. All right, so I've got some saying that it is and some saying it's not. Well, actually, it's not. And the reason it's not is that clone is not public inside object. So if you put in a clone method into your class, into your interface, it automatically becomes public and abstract. And this means that it counts towards my count, and as a result that this has two public abstract methods rather than just one, like the previous one. All right, now this one should be pretty obvious. Who says this is a function interface? The mouse listener extends event listener with 5 methods inside. Who says that's a function interface? Please don't put up your hand now. Please, nobody. Okay. It's not. This is clearly not. And the reason it's not is it's got 5 abstract methods. So it cannot be a function interface. And consumer, a predicate, and of course if somebody sees consumer, they say, producer consumer. Well, yeah, sort of, but not exactly. Predicate, function, and then unit operator and binary operator. Now, when I try and learn something new, I normally get very confused by looking at things like that. I always have to sort of figure it out first to see. And you can use a supplier when you want to supply an object later on. And so we've got two different methods, foo and a bar. And the foo prints logger.find, milliseconds since 1970, and prints out the current time millis. And the bar does the same, but uses a lambda. And if you look at the definition in Java 8 of find, it also allows you to have a message supplier to supply a string. And in this case, it doesn't actually construct the string up front. It constructs a lambda, which is going to construct the string at a later stage, if you've got, in fact, that level enabled. If you don't have that level enabled, then it simply throws away that lambda. So let's have a quick look at a demo of what an effect this will have. There we go. So this is my little IntelliJ here. And what I've done is I've made a logger inside. And foo says milliseconds since 1970 plus system.currentTime millis. Now, of course, we know that system.currentTime millis is a very expensive call, so it's going to be quite expensive to do this over and over again. And then you've got find, which has a lambda. And so it only constructs this very expensive object when it's really needed. So if you've got logging turned off, then you're not going to have the cost of the system.currentTime millis call every single time you want to print it out. All right, and then inside the main method, we're going to make a logging crazy. We then get the current time in milliseconds. We go from not up to the up to, and we call foo lots and lots of times, print out the time, and then we call bar afterwards to see how long that takes. We're doing it 100 million times, so that's quite a lot, and we expect it to take a little bit of time. In fact, let's start with 1 million times, just to so it won't take too long initially. So 1 million times, and we notice that the first one, the foo, where we construct the object every single time, even if you don't need it, is quite a bit slower than the second one. Okay, but our test was actually too short. You see, the problem here is that we didn't give it the test a chance to warm up. If Alexei Shipilev was in the room now, he'd probably kill me, because this is really not a very good benchmark. So let's up the work a little bit, make it 10 million times, and see how this changes things. So 10 million times, and you can see that that the difference is now much bigger, much larger. And what you probably want to do is to really see the difference. You want to actually call this over several times. So in other words, instead of just doing it once, we're going to do it 10 times, call test. And we can see that as the second one warms up, as the lambda one warms up, it compiles down to almost nothing at all. So it becomes really, really fast. The other one's like 300 times slower. And it doesn't get better as we increase this, let's make it 100 million times. It actually doesn't make it any better. It still is quite horrible. So this is what a supplier gives you. The supplier will allow you to construct objects lazily, only when you need them for the first time. So instead of passing in the object, you pass in the supplier for the object, and then the supplier is called when it's needed for the first time. It seems to be scaling relatively linearly, but as I said, this is not a proper benchmark at all. I'm not claiming it to be. I'm just playing around here to show you the vast differences between the various approaches. And of course, I've picked an example which is rather extreme, because I'm looking at, coring the system current on milliswitches, which is an extremely expensive core. Okay, so the supplier allows you to construct an object lazily. The consumer allows you to pass in an action that must be performed on an object. So if I've got, for example, a collection of names over here, and I say for each, I print out the uppercase. All right, so for each, this is sort of the old syntax. So for each one, this is the for each method is Java 8, but the new consumer, anonymous in a class over here, is the old from Java, Java 5 with the generics, but it's really very old. The modern syntax looks like this. We would say names.forEach, s, and then system.println.t.to uppercase, like that. Or what we could do is we can say names.stream, so we stream it, we then and then for each one of those, we again call another method reference called system.out.println. So we've got this nice feature of method references which we can use instead of using lambdas. So it makes it a little bit more compact, our code. It takes a bit of getting used to. The predicate is another little interesting feature. With the predicate, we can have a true-false come back based on a test. So for example, here I've got a collection of names, and I want to see whether or not each name contains the letter I. And if it does, then I return true, otherwise I return false. And so I can say names.remove if s.contains I, for example. And names.remove if can also be written as follows. I can pass in a lambda s minus greater than s.contains I. This is again another one of our standard function interfaces that are supplied in the java.util.function package. There's another one called function, which takes a string and returns an integer. So it takes one type, returns another type. You can, of course, have it take a string and return a string. That's quite acceptable if you want to do that. But there are also other ways you can do that. But typically, function would be used if you want to convert one type to another. So names.stream.map would take a function, passing in a string, and returning an integer, for example. What I'm doing here is I'm returning the length of the string. Okay, everything all right and steady? All good?
Yeah.
Okay, good. Now, you can also do it like this. You can say names.stream.map, s, and then s equals null. If that's true, then return 0, otherwise return s.length. So it makes it a little bit easier to work with. So again, another of the standard function interface that you can just use. Another one is a unit operator of type T that transforms a type, so transforming a T. So in other words, it's quite similar to the function. It's basically actually a function that takes a T and returns a T. So we can actually over here say returns a T. So T, T is probably a bit more accurate it's the same as a function TT. So if I want to replace all the elements inside a list, I could say names.replace all and pass in a new unary operator of type string, which would then, for each one of the elements, call s.to uppercase and returns that. Again, we can use either a lambda, a normal lambda, replace all passing an s, then arrow s.to uppercase, or in this case we can use the method reference to say string colon to uppercase. So this is sort of just the groundwork, very basic stuff about how the function interfaces work in Java 8. Now things get a little bit more interesting when we combine this with another nice little feature that we call default methods in interfaces. Now this part of the talk is a little bit more complicated than the previous. The previous one is quite, I think, quite easy, but this one is requires a little bit more concentration. There's a document called The State of the Lambda, written by Brian Getz and I think some other guys as well. And it's got a rather misleading example as a first example. They say, let's say you've got an action listener, and they say, you can, instead of having the action listener button.add action listener.new action listener, we can instead simply pass in a lambda. So instead of having the action listener explicitly taking an action event, we just take the action event E and we put it into the lambda. So we say the E is the parameter, it's a type action event, and we then say ui.dazzle e.get modifiers. So this is how it works with Java 8 lambdas. And when I first saw this example, I thought, okay, this makes sense. I mean, it's been many years since I've really been doing swing programming. Probably for most of you it's the same, but I do remember what it's all about and how you can add event listeners to buttons and to keys and so on. And so what I thought is, okay, so that's what they mean. Obviously normal listeners can be made into lambdas. And I then tried to, for example, add a focus listener. So this is sort of typical code, boilerplate code you would see in a project using AWT and Swing. You'd have a salary increase add focus listener, and then you say new focus adapter. And focus adapter is a class, an abstract class, which implements focus listener and overrides all the methods to be empty. Basically, it's sort of the same as default methods we'd have nowadays in Java 8. And so what they've done there is to you then lambdas for the same thing, but it didn't work because focus listener has two methods, so it wouldn't work. Let me just quickly show what the GUI looks like here, so you get some idea of what I was doing. Probably not this one. Let's run it, and you'll see it. So this is the salary calculator. I know that in Estonia you earn ridiculously high salaries as programmers. Doesn't want to let me increase the salary. For some reason I sometimes get it in there. I'm not quite sure why. There's some bug in this code that sometimes allows me to catch it. In the real world it doesn't work like that. In the real world you never can increase the salary. Okay. So what I want is to do something like this. I want to say, instead of saying add focus listener, I want to either say add focus listener and then pass in a lambda, but one that is and then use that nice lambda syntax. So once you use the lambda syntax in the context which it was not really designed for. Same with a key pressed listener. Instead of a key listener, I want to have a key pressed listener, a key released listener, a key, what is it else? Add mouse entered, mouse exited, mouse clicked, mouse pressed, mouse released. There are lots of different mouse events, mouse moved, mouse dragged. For all of those, I want to have methods. So that's what I really want to have. But how do you get there? So just to look back, if you look at a focus listener, this is not a function interface because it's got two methods. The reason why it was developed like this was because many years ago, people were very worried about the cost of classes. So they tried to minimize classes by not having too many different classes. And so they've had a focus listener. Of course, nowadays it doesn't matter so much anymore. We have lots and lots of memory, and a little focus listener is not going to make us run out of class space inside our perm space or meta space. But you can see here we've got two different methods for two different events. And then, as I said, the sort of typical hack in order to be able to use it more effectively was to make a focus adapter. And the focus adapter would have two methods, focus gained and focus lost. And these would be just basically default methods that do nothing, so that you can override only the ones that you want. So it's sort of a weird design. If you haven't used swing for many years, join the club. But this is not about swing. This is just an example. So the idea I had was the following: is instead of writing a button, a specialized button that has all of the different characteristics built in, I would make something called a mixin, where I'm mixing in code into existing classes. So all that I need is I need to be able to have a single method called add focus listener as an abstract method. Or actually my actual class would have to have an add focus listener as an implementation method, not as an abstract method. Now, one thing which is a little bit confusing here is that this focus event producer mixin happens to also be a function interface. But that doesn't matter in this case. It's completely irrelevant, because I'll show some other mixins which are not. So there are some which are and some which are not function interfaces. This one is, but many other ones are not function interfaces. The important part is that my buttons and all the other components I want to mix this into have got an add focus listener. Then I've got an add focus gained listener. This is a new method I've added to my interface. And you can see I've made it a default method. This means that I've got an implementation for it, a default implementation, add focus gained listener. It takes a consumer as a parameter, a consumer for focus event, and it adds a focus listener. And the focus listener, when the focus gained event happens, it calls the consumer.accept the E, which is a focus event, a type of focus event which is coming in over here. This means that I've made a new method which I can mix into an existing class for allowing me to add a focus gained listener rather than just a focus listener. And then I've got a focus lost listener. And again, I've got add focus listener that I pass in a focus adapter, and now I'm overriding the focus lost method. The focus lost method is going to call the consumer.accept either against, again, the event.
Heinz.
So that's sort of the...
Heinz,
yes?
I need to interrupt. We have only like 2 minutes left.
Okay, no problem.
Sorry.
We'll manage in 2 minutes. So what we do is we have a focus gained listener. The focus gained listener calls an abstract method, add focus listener, which is an interface. And this method is part of the button. Okay. So inside my button, what I would do is I would simply extend JButton, my JButton lambda, and then the JButton lambda would implement the focus event producer mixin. All right? And so this allows me to say the standard increase that add focus gained listener and pass in a lambda, which is our consumer for this event. Now, this is at the most basic level. What you can also do is you can for each of the different components, you've got different types of listeners. So, for example, component would have add focus listener, add mouse listener, and you can see all the way down to abstract button, which is an add item listener. And the J component mixin would be for all of the mixins from all the other classes all together. You can see here now it's no longer a function interface. It has lots and lots of methods. And the abstract button mixin would have abstract methods that we can use that as an abstract supertype for any type of button that we use. So we would now make a JButton lambda. Focus, hierarchy events, everything's available. And also the abstract button event producer mixin, so it's got the action listeners as well inside there. Right, so there are also other ways of doing it. For example, what you can do is you can have sort of a facade for each listener. So you can have a full focus gained listener returning a focus listener. And the way that this code would look is as follows. You would say salary increase add focus listener, which would say focus listener full focus gained listener, and this way you don't have to change the interface, you don't have to subclass JButton in order to mix it in. Well, it's not mixed in, it's external, but it also still allows you to have the lambdas, but with extra method call.
Heinz,
we'll skip over this because you don't have the time.
Heinz, yeah, I need to interrupt. We need to finish. Yes, conclusion, please. Thank you.
Right, if you'd like to see more, have a look at this URL. And Java 8 was released in 2014 March. It's going to take a while for this to become mainstream in companies. This idea that I showed you with Mixins has other applicability as well. I won't go into the details here, but I've seen it in some examples where it would work very, very nicely. So thank you very much for participating, and put up your hands very nicely, and see some of you hopefully tomorrow.
Bravo, thank you.
Thank you very much.